This is Foundations of Math in Pre-Calculus 10, Chapter 1.1. We're going to be looking at the SI measurement system. And in Canada, it was adopted at the beginning of 1970 by Trudeau. The SI units are meters, Kelvin, grams, second, and candela. This is for luminosity, and mole for the amount of substance, and ampere. And from the SI measurements, we use metric units and makes conversion to larger or smaller units easier, i.e. by powers of 10. And this applies to the meter, gram, and liter. A liter is 1,000 cubic centimeters. But for this chapter, we're only concerned about length, and that's the meter. So here's a conversion table. And this conversion is getting smaller units. So because we have smaller units, we have more of them to make 1 meter. And here we have larger units. And again, we have fewer of these to make 1 meter because it's larger. So get used to which ones are larger and which ones are smaller. We want to notice the prefix. The prefix is the same for any metric unit. So it applies to grams and to liters. Although you're unlikely to find measurements this small for volume. Okay, before we get into any conversions, let's review some formulas. The area of a rectangle is length times width. The area of a square is length squared. The area of a circle is pi r squared. And the area of a triangle is 1/2 base times height. And to get the perimeter, we have 2 times L plus W, or you can have 2L plus 2W. The perimeter is 4L, and the perimeter of a circle is 2 pi r. There is no formula for the perimeter of a triangle because it's not consistent. And for volume, volume of a prism is length times width times height. The volume of a cube is length cubed. Volume of a right cylinder is pi r squared h. So this is a right cylinder. And the area is 2 times length times width plus width times height plus length times height. And for the area of a cube, we have 6 times length squared. And the area of a right cylinder is 2 pi r squared. So this is for the top and the bottom. And then the lateral surface area is 2 pi RH. And in case you need to remember, top and bottom. And this is the lateral. Okay, lateral just means the side. Converting SI units. Now, to reduce errors, always write the units. And this is called unit analysis or dimensional analysis. So let's convert 7.5 kilometers to centimeters, 7.5 kilometers, times 10 squared centimeters and 10 to the negative 3 kilometers. And where am I getting these numbers from? We go back up to the table. So we have 100 centimeters, so that's 10 squared. And we have 0.001 kilometers, and that's 10 to the negative 3. Okay, why are we writing down the units? Because we can do unit analysis. We cancel out the similar units. Kilometers over kilometers is just 1, so they cancel out. So this equals 7.5 times 10 to the 5. So we do 2 minus negative 3, so that's 2 plus 3 centimeters. So you can leave it in scientific notation, or you can convert it to just a number. So we want to move the decimal place over 5 times. 1, 2, 3, 4, 5. So always do a mental check, and that will help avoid errors. So when we go to a smaller measurement, or smaller unit of measurement, this will make the number larger. And going to a larger measurement unit will make the number smaller. So we're going from a large to a small, so the number's getting bigger. So we started with 7.5, and we ended up with 750,000. Okay, this time we're going to change 350 millimeters to hectometers. So we have 350, and we write millimeters. Times, we have 10 to the negative 2 hectometers, and there's 1,000 millimeters in a meter. So this is 350 times 10 to the negative 5 hectometers. Again, the millimeters cancel out. We have 10 to the negative 2 minus 3, so that's negative 5. And if we wanted to move the decimal place over, we could write 350, and we need to move it over 5 times. 1, 2, 3, 4, 5. So the decimal place, 2 zeros, hectometer. Okay, change 24 meters into micrometers. So 24 meters times, there's 10 to the 6 micrometers in a meter. So this just becomes 2.4 times 10 to the 7 micrometers. We cancel out the meters, and all our units are good. Okay, change 37 decimeters to decameters. So we have 37 decimeters times 0.1 decameters and 10 decimeters. Okay, so there's 0.1 decameters in a meter, and there's 10 decimeters in a meter. The decimeters cancel out, and we have 0.37 decameters. Okay, so 0.1, and this is 10 to the negative 1, and this is 10 to the 1, so we have 10 to the negative 2. So that means we move the decimal place twice to the left. Okay, let's do some applications with our unit conversions. Let's look at scaling and ratios. We always want to keep the same object in the numerator and denominator. I'm not going to make you use a ruler because printing this doesn't get it to scale all the time. So we're going to use grid units. Each grid unit is 7 millimeters. The scale reduction is given to you as 1 to 1122. Determine the length of this 747-200B. So we count the number of grid units. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 times 7 millimeters. This equals 63 millimeters. Now we take the 63 millimeters and we reverse the scale reduction. So this is multiplied by 1122 over 1. And if you bring up your calculator, you get 70,686 millimeters. Is this a useful unit to use? No. So let's convert this into meters. 7,686 millimeters times 1 meter, and that's 1,000 millimeters. Cancel out the millimeters. Move this decimal place over 3 spots, and we get 70, and we'll round that off to 70.7 meters. Okay, so that makes sense. This is almost the size of a football field. Let's look at another example. Each grid is 7 millimeters again. The scale reduction is 1 to 176. Determine the length of this Integra Aspire motorhome in meters. So we count the grid units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's an easy unit. 10 times 7 millimeters. That's 70 millimeters. We take the 70 millimeters. We multiply this by 176 over 1. And we get 12,320 millimeters. Again, not a useful unit, so let's convert this to meters. 12320 millimeters times 1 meter over 1,000 millimeters. And that equals 12.3 meters. Okay, that's a pretty long motorhome. And this completes part 1 of chapter 1.1. And we'll continue on next time with part 2. And that completes this lesson.